A moving box has a mass of 10 kilograms. It sits on a carpeted floor where the coefficient of static friction μs is zero point 0.7 and the coefficient of kinetic friction μk is zero point 0.3. The question is to find the acceleration in the following situations. For part A kid pushes on the box with a 15 Newton force. We use the particle model, and as such, we represent our object, the box, as a dot. We also construct an x-axis and y-axis, and then identify the forces that are acting on the object. So along the x-axis, we have the pushing force of 15 newtons to the right and frictional force to the left. Similarly, vertically, we've got two forces, which are the weight represented by mg, and we got 98 newtons by multiplying our mass of 10 kilograms by gravitational acceleration of 9.8 meters per second squared. There is also normal force, which is acting upwards and perpendicular from the surface. The next step here is to apply Newton's second law of motion to its axis. We start with the vertical axis. The assumption here is there's no acceleration or there is equilibrium vertically, so the sum of the forces along the y will equal to 0. This will be our working equation. All forces upwards will be positive, and so that's the case for normal force, and all forces acting downwards will be negative, and that will be the case for weight. So our sum of forces equal to 0 along the y-axis is then positive normal force minus mg equals 0, or since we're given the weight, we can write it down as normal force minus 98 newtons is equal to 0. Here we can see that the normal force is 98 newtons. The frictional force present, which is actually static friction, has a maximum value equal to the product of the coefficient of static friction µs and normal force. So when we multiply our static friction zero point 0.7 coefficient by our normal force of 98 newtons, we get 68.6 newtons. When we solve for the maximum kinetic friction, then it will be mu kinetic, which is zero point 0.3 multiplied by the same normal force of 98 newtons to give us 29.4 newtons. Therefore, the value of maximum friction static is 68.6 newtons, and the value of kinetic friction, which is constant, is 29.4 newtons. Next, we apply Newton's second law to the x-axis, where the sum of forces along the x is equal to mass times acceleration. And two forces are on the x-axis. Again, forces to the right are positive, which is the case for the pushing force, and forces to the left are negative. In this case, it's friction. So we can rewrite this equation as sum of forces along the x as 50 newtons positive added by a negative frictional force, and that's equivalent to mass of 10 kilograms times acceleration. So in this equation, we can see that the applied force of the person is 50 newtons. However, the maximum static friction between the box and the surface is 68.6 newtons. Therefore, the applied force is not enough to overcome the static friction between the box and the floor, so the object will not move. Therefore, the acceleration is 0. Here, acceleration of 0 means there will be no change in the velocity of an object. while the initial velocity is zero because it was at rest, and therefore it will continue to stay at rest.